This is experiment 1, looping and branching statements, and I'll be executing my first program of the exercise. Now what this program basically does is it prompts the user to keep entering numbers till the user desires. So basically I'm running an infinite for loop which allows the user to enter as many numbers as he wants, and after each entry it asks the user whether he or she wants to continue. If they want to, press Y, which will check if the character they've entered is Y, which I'm storing in CH. So if they've selected Y, then it will continue and take it back to the beginning of the loop. If they choose any other character, it will break and bring them out of the loop. And finally, it will print the number of positive, negative, and zeros that the user might have entered. Now I'll execute this program. Enter number, I'll enter 8. To continue, press Y. -9, 0. Continue, press N. So here it is. You can see it brings me out of the loop of entering numbers, and finally the amount of positive, negative, and zero count is printed. Okay, so this is the second program of the exercise where I prompt the user to enter the number of hours required to install a hardwood floor. It displays the number of complete 8-hour workdays required for the job, as well as the remaining hours needed in the last day. And finally, I have to compute and display the total cost of the job at 200 per day plus 40 per hour for the partial days, if at all there are any. So here I initialize my variables, and I enter the total number of hours. So what PD is doing is it's storing the remaining hours by calculating hours mod 8, and WD is storing the working days by dividing it by 8. So here it will store the remainder, and here it will store the quotient. So finally I will print the working days, and then I'll calculate the cost based on the specifications given. Finally I'll execute this. Say for example we enter 25. So as you can see, remaining hours is 1 because 3 8s are 24, and obviously 1 is remaining. Working days 3, and total cost 640. So this is my third and final program of the exercise. Now here I accept a choice from the user, and based on the choice I calculate binary to decimal, and if it's 2 I calculate decimal to binary. So I have already declared the variables that I'm going to use in the cases. So let us begin with case 1. Here we prompt the user to enter a binary number to convert to decimal. Enters the number, we store this number in temp, and we calculate the decimal value using temp so that num remains unchanged. Now what decimal is doing is it's storing the decimal value when remainder removes the last digit every time the binary number is calculated using temp divided by 10. So we have rem into b, which is basically doing the bit into 2 raised to n. So n starts from 0 and goes till whatever the length of the binary number is, and finally we print the decimal equivalent of the number. Now case 2 has it prompts the user to enter a decimal number which will be converted to the binary. So we store the number in dn and we calculate its binary value. Now we run a we run a for loop using j is equal to n to greater than 0 and j is equal to j divided by 2. So what this bin is doing is it's storing the binary equivalent of every time we run the j loop. For example, say if we take 4, this loop will run till the n divided by 2 is n divided by 2 is satisfied until j is greater than 0. So let's say for example 4 we do binary is initialized to 0. So n mod 2 will be 4 mod 2 which gives us 2 into I is 1, and since it's 0 it will be 0 plus n mod 2 will give us 0, and finally I into 0 won't matter. I will just change to 10. N mod 2, this will give us 2, n will be changed. The same process will be carried out. Again we'll get 0 will be stored in binary. I will be changed to 100. Finally n is equal to n divided by 2. So now what we get is 1 satisfies the j condition, and finally it brings you out of the loop and the binary equivalent will be printed. I'll execute this. Say for example we enter 1 which is binary to decimal, enter a binary number 1000 which should give us 8, there it gives us 8. Now for choice 2, enter a decimal number to convert to binary 4 which should give us 100, there we have it. So I have executed all my 3 programs and the output has been verified.